Hey everybody, welcome to the Daily Space Weather Show. The Filament Fest continues. Just check it out. And we've got no less than 3 coronal mass ejections headed in Earth's direction. Another exciting day for space weather. That's the past 24 hours from SDO, featuring ionized helium and ionized iron, 304 plus 193 angstroms respectively. And yeah, massive plasma filaments here. We're going to start out by taking a look at the northern hemisphere, where there is a huge crown prominence that may be associated with the largest filament we've covered in like 6+ years of daily space weather videos. So here's a great view of this insane crown prominence. And we placed the bar scale there just to show you the size of that dense portion of that filament over there on the left. 44,000 kilometers. The approximate size of that small portion of it. We'll zoom in even more closely here. Now we've replaced the Earth scale with the bar scale with the Earth scale, I should say. Great view of that crown prominence. And you can expect to see more features like this in the coming year plus as we ramp up and up and up to solar maximum. We're continuing to see higher highs and higher lows in things like sunspot number and the radio flux progression. Great view of that crown prominence there. And let's zoom out to the equator view. There you go. The largest flare player has been this sunspot group down here, which has been growing quite nicely in the past 24 hours. It's produced 2 coronal mass ejections, and another CME came from this group. All 3 of those likely have an earthly directed component. So we've got 3 CMEs headed in our direction. You can expect those to start to arrive sometime around midday on October 11th. Yeah, October 11th, around midday. Coronal mass ejections will start to hit no less than 3 of them. October 11th and October 12th should be interesting days for space weather. Here's where the action came from. It came from that sunspot north of the Earth scale. The latest one came from this area right over here. You can see a hider flare right in there. You'll see a sudden brightening as some of the material splashed back down toward the solar chromosphere. Some of that material is now headed in Earth's direction. So 3 CMEs, 2 came from this area, and 1 came from this area. They're going to start to arrive on October 11th, sometime after midday. We'll show you more detailed imagery about that here at the Smash News Network, least busted name in news. And before we do any of that, let's take a close look at this rapidly growing sunspot in the southeast, and also another sunspot. It's of decent size. Rose in the southeast as well there. So to the left of the Earth scale, there's a rising sunspot there, and a rapidly growing sunspot to the right of the Earth scale there, or the west. Also, you can see a hider flare or 2 happening there, right there. Some material splashes back down toward the chromosphere. That is when plasma stops being suspended by magnetic fields and succumbs to gravity. Do you understand the gravity of the situation? Well, here at the Smash Weather News Station, we like to get a standing ovation from the human population. Here's a close-up of that new rising sunspot and that new rapidly forming sunspot. By the way, if you enjoy the content, press all of the things, like the like button. If you're new to the channel, press the subscribe button. It's only the most comprehensive daily space weather content you'll find in the known universe, incredibly, shockingly accurate forecasting, meteorology segments, and even commentary about things that might not even have anything to do with space weather. So press the things, press the share, the comment, etc. Thanks to our new subscribers over on YouTube. Congratulations on realizing the channel exists. We're frankly surprised. So, yeah, it's very controversial to cite so many facts per day, so sorry about all the controversy there, folks. Press the buttons, and you haven't pressed the buttons yet, so I have to wait now. I have to wait for you to press the buttons. Yes, we can detect your pressing of the buttons, so press the like button. Press share. We'll wait for you to share and put a comment on Facebook so that the post isn't shadow banned. Yeah, don't just put a link. You got to actually, and don't just put an emoji. You got to actually type something. So otherwise, your posts will be deboosted. So press the things. Also, help us to increase the probability that these videos will continue to exist, remain publicly visible, and free for all to view by patronizing our paid affiliate/sponsor links. One of those is the Amazon shop, amazon.com/shop/smashomash. If you haven't switched to organic coffee, well, it's highly recommended. You can find a fantastic deal there. The Amazon shop is linked below this video to the Cameron's Scandinavian Blend Whole Bean Organic. Yeah, this isn't a health claim, folks. However, when we switched to organic coffee, we stopped getting the jitters from coffee. Now, I'm super chemically sensitive, and I'm a lightweight when it comes to caffeine. But yeah, when we switched to organic coffee, we stopped getting the jitters. So why not try the Cameron's Scandinavian Whole Bean Organic? It might look expensive at $31.59, but that is a 4-pound bag. So it's probably less money than you're paying at your grocery store if you're buying organic coffee. And if you're buying non-organic, cheap, junky coffee, that's on you, man. But anyway, yeah, so help us out with our affiliate/sponsor links. That is a 4-pound bag. It looks like this. We keep it in the freezer. Always smooth, never bitter. Another affiliate/sponsor link you can find is to our Hemp Lucid shop. So if you're in the market for some CBDs, mushroom gummies, stress sleeper immune stacks on which you can save $15 each or even more on the full stack package, hit up our link below the video to the Hemp Lucid shop. Try out some of those products, Delta 8s, body balms, and so on. There are those massive savings on the stress, sleep, and immune stacks. And they've got the lip balm back in stock now. So they make great gifts. They make great gifts and give your biological workings a lift, perhaps, with some Hemp Lucid products. Last but not least, today's featured product is Do the Math, which features an ultra-high resolution image of the core of the Milky Way galaxy. Yeah, that's Sagittarius A star. And we've shown our work. Hopefully you don't suck at math, but here's the equation. 8 == capital D. Feel free to use it on social media, folks, as we're not going to try to copyright a math equation. However, again, we hope you don't suck at math, and if you're spooked of the galaxy, you certainly suck at math. Galaxy, not scary. If you're spooked of the galaxy, here's the work. 8 == capital D. Don't suck at math. Do the math. Do visit our links. The Redbubble shop linked below the video, as well as on the homepage at smashomash.com. And let's get back to the space weather. The weather in space. Yeah, space. It's not empty. Here's what's going on between Earth and Sun. Oh, one more thing. Become a member of the Smash Team. If you want additional content, smashomash.com/Smash Team, our custom subscription services site. The best value is the gold annual paid-up subscription. It's like getting 4 months of a gold membership for free. There's also a silver and a bronze level membership, smashomash.com/Smash Team. And there is the latest SDO Continuum. So we do have a new sunspot, which might get a name up here. It's pretty small and pretty diffuse and weak. But this one down here has grown rapidly, and at least one more sunspot has formed right up here, and another one formed down here. So we'll have at least 3 new named sunspot groups today. Cheers. Or at least 2 new named sunspot groups today. This one that rose over the southeastern limb, and this one that formed up here. So yeah, another increase in its sunspot number coming. We do have a very high likelihood of large solar flares continuing. Here's the colorized magnetogram. Like the SDO Continuum we just showed, that is the Solar Dynamics Observatory colorized magnetogram. It's depicting October 7th and October 8th to date. So that's what's going on. Let's take a brief moment to turn around and take a look at Earth and see what volcanoes are erupting. Mount Ibu's exploding, flight level 070. Takono's exploding, flight level 070. It's also a 7,000-foot ash plume over the Indonesian isle of Halmahera. Fuego exploding in Guatemala, flight level 160. Flight level 200 over Sangay in Ecuador. Sabancaya in Peru, flight level 260. And Ubinas also exploding, flight level 180. That's an 18,000-foot ash plume. Looking at seismic activity, it's a lot more calm than it was yesterday. Yesterday's video had a berserk number of quakes, and the quakes in Afghanistan have caused the deaths of over 2,000 people, because like I said in yesterday's video, 6+ magnitude quakes in Afghanistan have a tendency to turn ancient buildings to dust, which is exactly what happened. Anyway, these are the quakes over a 5 magnitude, of a 5 or greater magnitude. And we did have a few here to round out the day yesterday. 5.5 at Papua New Guinea, a 5.2 at Papua New Guinea. Those were within 6 minutes of each other, and then a 5.1 on the Isle of Honshu, Japan. That was at 14:26. And then a 5.7 at Papua New Guinea at 16:20 Universal Time yesterday afternoon. And then a lull in 5 magnitude earthquakes until another 5.1 at Papua New Guinea. Aftershocks continue there following a pair of 6.7 magnitude quakes early in the day yesterday. Next, a 5.0 at the Fiji Islands there, north of New Zealand. A 5.2 south of Japan. Another very active region in the past week. A 5.0 there in South America, right on the west coast of the South American continent there. That was at 7:28 this morning. And that is the end of the list. Let's get back to space. Here's the past 24 hours from SDO 171 angstroms wavelength. And you might see 2 things happening. Again, the major events here are Earth-directed CMEs, 2 from here and 1 from over here. We'll cover it. First, let's talk some more stats. The 10.7 centimeter radio flux is now at 157 solar flux units. If you're wondering what a solar flux unit is, it is 10,000 Jansky, which is a measurement of radio flux density through space. The 10.7 centimeter radio flux discovered in 1947 by some Canadian World War II radio users discovered the 10.7 centimeter radio flux, and it's still monitored in Canada to this day. There's the 1-year graph. The black line is the radio flux. Again, 157 is the new number, a small uptick from yesterday. It's gone like 155, 156, 157. I would note the higher highs and higher lows on both the radio flux and the sunspot number. You see this recent trend. We are still ramping up towards solar maximum. We're nowhere near solar maximum yet. These are facts. Next, Space Weather Enthusiast dashboard here, not forecasting any geomagnetic storms or geomagnetic unrest. It's going to be calm until, like I said, the 11th. Then we're going to have 3 CME impacts starting around midday the 11th. At the moment, the solar wind is extremely diffuse. And let's take a look at Earth's magnetic moment from space. Solar wind extremely slow, actually. The solar wind density came up a little bit. This is the past 4 hours of what Earth's magnetic moment from space likely looks like. The space weather modeling framework is depicting magnetohydrodynamic pressure. Again, a very slow solar wind with a slight uptick in the density in the past couple hours, in the past hour actually. Here's Earth's magnetic moment from the ground. Again, it is geomagnetically calm. So that is the past 4 hours of magnetic flux density on the Earth level. And if you're spooked that the poles are going to flip, how come it's not showing up on that map? Not even a geomagnetic excursion, folks. Not even a geomagnetic excursion. Not even a blip on the geologic radar. What we're currently seeing, the spooky, spooky pole shift. Oh no, everybody's very spooked. Everybody's very spooked and should probably look into actual facts about the strength of the magnetic field, cosmic ray flux, and these sorts of things. Current conditions as far as geomagnetism are a KP 1.67. If you're new to the channel, that is an average of global geomagnetism, the KP index, the planetary K index, whatever you want to call it, KP 1.67. And let's take a look at the solar wind. So again, we did see a little uptick here in the solar wind density, coming up to over 16 protons per cubic centimeter there. So a little bit of an increase there. Could be an early arrival of a coronal hole high-speed stream. The density spike is often what we see preceding the high-speed portion of a coronal hole high-speed stream. If so, it is arriving a little earlier than we would expect. But so far, the solar wind velocity here extremely low, barely over 300 kilometers per second. That is what you typically see at solar minimum. 309 kilometers per second there for the solar wind speed, very slow. Solar wind density has come up quite a bit here to 12.14 as measured by the Discover spacecraft at Lagrangian point 1. Those magnetometers here are looking chill, no surprise there, with space weather at such a low level. Next, the top view ecliptic plane field plot. There is a sector boundary crossing coming. I'll let that play through one more time and then bring up the last image. So there's the last image. Sector boundary crossing looks like it's about 2 days out. Earth will move from a South Pole current sheet into a North Pole current sheet, assuming nothing suddenly changes. And we could actually see that show up as early as later today if we see continued growth and more sunspots showing up in the southeastern limb. So that could be an acceleration happening, or we could actually be seeing the likelihood of a new sunspot forming in the northeast as well. So a couple different things happening there, a couple different facts there correlated with the top view ecliptic plane field plot. It depicts the polarity of the solar plasma. That is the heliospheric current sheet. Next, our line of sight field plot. We show it daily on the channel as solar cycle progression evolves before your very eyes. This data, some of the most important data in the world. Sure, the SDO is totally awesome, but this is just right there at your fingertips, folks, the line of sight field plot. It's, if you don't know, you don't know. But if you know, you know. Cheers. And here's our coronal hole line of sight plot, and we've got a well-defined South Pole-oriented coronal hole, and you can expect to see more well-defined coronal holes in the coming 2+ years. Because solar cycle progression. It's just a fact. We've got some North Pole-oriented coronal holes here rotating in as well. Let's take a look at SDO. That is SDO 211 angstroms wavelength for the past 24 hours. So that coronal hole is likely to produce some geomagnetic activity on planet Earth as well. That's still about 4 days out. And it is of South Pole orientation. We do have some North Pole coronal holes here rotating in behind it. They're just coming over the limb now. They're not really visible yet. Why? Because of all this bumpy plasma. The bumpy plasma over here. It's blocking the view of those coronal holes of North Pole orientation. They will become more well-defined in a day or two. And there's the full disk view. And let's move to sunspots. So here's a sunspot scenario, sunspot number. There it is, as reported by the Royal Observatory of Belgium. Now coming back up to around 150, so it's about 148, it looks like, according to that imagery. Higher highs and higher lows. Expect to see those continue for over a year because we're nowhere near solar maximum. Next, our flare monitor. And we have an increasing likelihood of large flares, especially from this series of sunspots in the northwest. As they get closer and closer to the limb, their likelihood of producing a large flare gets higher and higher. Also, this sunspot group has been producing significant flares, including an M-class event. And this sunspot. So 3 spots capable of producing large flares. According to the flare probability monitor here, the most likely spot is indeed remaining this sunspot up here in the northwest. Again, it becomes more and more likely to produce an M or an X-class event the closer it gets to the limb. Here's the past 24 hours in SDO Continuum plus 171 angstroms to highlight the active regions. Note the growth and action now happening in the southern hemisphere. 2 active sunspots down there have been producing activity. Let's subtract the 171 angstroms. There's the continuum by itself. This sunspot up here will probably get a name today. That'll increase the sunspot number by quite a lot. I can see at least 3 or 4 umbrae that'll likely get counted there. So that'll be, let's see, that'll be an increase in sunspots of at least 18 just from that group. This sunspot down here has gained umbrae. That'll increase sunspot. Let's see, we'll be pushing 200 sunspots again here, folks. We'll be at, let's see, we'll be at 170 once this one gets named, assuming none of these other ones evaporate. And that'll be before this massive group sets. It's another solar uptick. Oh, and of course, there's this group up here. I don't think that group has a name yet, does it? Let's go back. Oh, that group doesn't have a name yet either. So we'll have like 4 new named sunspot groups. Yeah, another significant solar uptick is in progress. And for sake of completeness, we'll also show the SDO magnetogram. It's exciting times for space weather, and it's only going to get more and more exciting, especially as the focus by humans continues on things like private space flight. It's just getting more and more exciting. Eventually, you're going to be able to go into space without having to pay 6 figures for it. That'll be in less than a decade, probably in about 3 or 4 years. So, yeah, I mean, we didn't just leverage ourselves here accidentally. I nearly majored in cosmology in the mid-1990s. I guess I'm dating myself now. Let's get to energetic particles and solar flares. We ain't got no energetic particles, but now it looks like a channel's opening up. So now the likelihood of solar energetic particle events is much higher. So don't be surprised to see some spikes in the proton flux, some polar radio blackouts, and some equatorial radio blackouts from flares, as they are becoming increasingly likely with the growth of those southern sunspots, as well as the setting region in the northwest. So there you can see an uptick in solar flare activity. The background level of X-ray flux has now come back up over a C class. It is now background flux of about C1. Largest flare of the past 24 was this M-class event, an M1.8, approximately at 1800 universal time. That was associated with an Earth-directed CME. We'll show you that in a minute. First, the past 24 hours in SDO 131 plus 94 angstroms. So the most active sunspot has been that one in the southeast. It was the location of that M-class flare. There's a closer view of that. And here's an even closer view of that. Leave us a comment and press the thumbs up button if you think that is a money shot. Money shot, a word you're still allowed to say on YouTube. And let's take a look at some more chill stuff, shall we? As that is some very hot plasma. The extreme ultraviolet emissions from ionized iron in the sun's atmosphere. Here's something a little more calm. What's going on overhead? This is our skies above Lehigh Valley at the time we created this video. You've got the moon, you've got Venus chasing, you've got Mercury chasing Venus and the sun chasing Mercury and Mars chasing the sun. Jupiter has just set in the northwestern sky. That is what's going on overhead. That's skyandtelescope.org's planetarium sky chart. And we've got Vega peeking over the horizon there in the northeast. Next, the solar system forecast. We show it daily on the channel. That's where things are today. We'll advance this 1 week. Here's where things will be in a week. It'll be the new moon on the 15th of October. October 15th is the new moon. So do a thing that you're supposed to do, like start a new project or something. I don't know. What do astrologers say? Something about, you know, the new moon. You're supposed to, like, do a thing or something. I don't know. Whatever. It's interestingly enough, astronomy is looking more and more like astrology as more information comes out about things like cosmic ray flux. But we'll save that for a different video. Here's our astronomy photo of the day, and that's a pretty sweet one. It features the moon, the sun, clouds, a plane, and a massive sunspot from 2014. apod.nasa.gov if you want to check it out yourself. A partial solar eclipse there, a massive sunspot, one of the largest ever recorded, a plane, and some clouds. apod.nasa.gov. And let's get to coronal mass ejections. It would be neglection to not cover coronal mass ejections, and we've got 3 on the way to Earth. So right around 1800, you're going to see one, a very diffuse, stealthy one, come out of the southeastern portion of the solar disk. That's got earthly directed components. Part of the reason why it looks so diffuse is because it's headed right toward Earth. So that's almost a direct hit, although it is a small diffuse coronal mass ejection. You can expect that one to arrive sometime around late day on the 10th, possibly midday on the 11th. But most likely like around midday on the 11th is when you can expect to see that one arrive. And then there are 2 more CMEs from this morning. And those both likely have earthly directed components as well. So that's interesting. So 2 more CMEs there. Those will be likely to arrive late in the day on the 11th and into the 12th. So the 11th and 12th especially, expect coronal mass ejection impacts, possibly starting as early as on the 10th, but more likely very late in the day on the 10th, early in the day on October 11th. Facts. Pardon all the facts, folks. Those are facts. So, and let's show you some more detailed imagery here. This is what's going on. Let's bring this one back. So here's the first one. This one's quite stealthy. You can barely even see it. It is headed right toward Earth. Right in there, you can see a little bit of a signal there coming out of the southeast. That was associated with that M-class flare, by the way. It didn't blast off a lot of material, but it is headed toward Earth. Next, this morning, there's another one at about 0400. And then there's another one. And the final one is actually the most significant one headed toward Earth. This one right here around 7 o'clock. So let's show those. We're going to show those from the GOES 16 SUVi. So here's our Twitch stream from yesterday. And here's this first CME. You're going to see it come out of this sunspot right here. So there it is. There's an M-class flare right there. And then you see some material coming out. That is headed directly toward Earth. That's the first Earth-directed CME. And then quite a bit later in the day, actually early in the day today, let's move this forward. we've got an unfortunate eclipse happening there. Let's bring this back a little bit. All right, here we go. Here's the next CME. This one happened at about 0300 this morning. It came from this area once again. So that's the second. That'll likely have an earthly directed component. Most of the material went off to the northeast in this direction. But because of its location on the solar disk, it is likely to have an earthly directed component. Last but not least, a third CME came out of this sunspot area, right around here. Let's see. And there you go. There's the propagation of that third coronal mass ejection. This one is going to be the most significant one, believe it or not. This one is headed directly toward Earth. Right there, you're going to see some material splashing down, an event known as a Hyder flare. Some material is indeed headed our direction. So, facts. There you go. And we're going to show those again here now just on coronagraphs. So here's the first one. You'll see this coming out of the southeast right there. Kind of stealthy, because when a CME is moving directly toward the coronagraph, it takes a while for it to show up. It looks more diffuse than it actually is in that case, as it's obscured behind the disk. Next, there's that one coming out of the northeast. That likely has an Earth-directed component. And then very shortly afterwards, one coming out of the south, also an earthly directed CME. So we'll just let those play through again for your viewing pleasure. We'll also show them from Stereo A's perspective. 3 new coronal mass ejections headed toward Earth. You probably heard it here first. We don't wait for NASA and NOAA to model it. NASA and NOAA should be watching our videos. NASA and NOAA, you are invited to watch our videos. We'll also show Stereo A, just to show some additional corroborating data. Feel free to pause the video on this frame. If you're not familiar with the locations of things like Bepi Colombo, Mercury, the Sun, Venus, Stereo A represented by that red circle, the Solar Orbiter, the Parker Solar Probe, Stereo B represented by the blue circle. All right, let's bring these back. Raw coronagraph on the left, difference imagery on the right. Here's the first CME from yesterday. Right. Not even visible there. The next CME is at about 4 o'clock this morning. That one will be definitely visible. That one's quite significant there, coming out of the northeast. And then a second one almost right afterwards there, coming out of the south. All 3 earthly directed components. Period. Facts. Next, filaments. And check out the filaments. Geez. There's a situation from Cerro Tololo, Chile. And DAG. Hey, it looks like this one might be getting unstable here, folks. So that's exciting stuff. Check it out right there. You can see some activity happening there. This filament is absolutely gigantic. The largest filament we've covered in 6+ years of doing daily space weather content. Also, look at these filaments. Huge, 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 huge. So a lot of those filaments could get names. Follow the hashtag #NameThatFilament and the hashtag #SpaceWeather over on Twitter. Don't worry if you've unplugged from social media entirely because of the pathetic censorship, the pathetic, evil, corporatist, ridiculous, un-American, nonsensical, illegal censorship. We don't blame you. Look at the filaments. Dag! That is a berserk number and density of plasma filaments. So there is certainly a high potential for coronal mass ejections. There's a 99.9% chance of those continuing. Like, expect CMEs on tomorrow's daily space weather video. I mean, that's a lot of plasma pointed at planet Earth. Again, if you want to name filaments after living people, do it over on Twitter. x.com/smashomash is the Twitter feed. I'm not calling it X. That's not a brand. That's a letter. By the way, you can't trademark a letter. A letter is not a brand, nor will it ever be a brand. Thanks to our new followers over there on Twitter. We just put up an advertisement for our custom bath mat. Yeah, place your feet on the face of evil daily with the Tony Fauci fraudster face of evil bath mat. Links on the Twitter feed. Yeah, I've got my foot on the face of evil right now, folks. I've got a Fauci face of evil bath mat right there. Yes, it's so fun. Fauci wears a red mask, yes, says you should wear too. Here are the past couple of hours from the GOES 16 SUVI, and that crown prominence looks like it's getting unstable. It may be associated with this massive filament too, so this might be sort of one plasma feature here. If so, it could all be connected. It could all release at once. It's becoming less and less likely to be earthly directed if it does all release at once. So, I mean, that might be good news for some of you. I don't know. You might be frightened that the sun's going to kill you. So, you never know. We try to create videos that will appeal to all humans, even if you're in a cult. So anyway, that's the past couple of hours from the GOES 16 SUVI, and that crown prominence is pretty berserk. Let's zoom in on it. Dag. Holy cripes! Dear God. And that brings us to bonus features. So we're going to blast through bonus features and then do meteorology. First bonus feature is satellite charging hazards. We ain't got none. It's smooth sailing for satellites at the moment. According to the Satellites Community Dashboard, the GOES electron flux here has dipped. So that could be the early arrival of a coronal hole high-speed stream density wave, folks. So that could be a thing. GOES electron flux there having dipped. That's the past 3 days of radiographic measurements taken from the geosynchronous near equatorial orbits, the GOES 16 and GOES 18. There's the 1-year graph. You can expect to see that dip when that updates today. A little bit of a reduction in the electron flux at the F layer of the ionosphere. There's the forecast model, and it looks like NOAA forecasted that dip in the electron flux this time. So, looks like a minor and relatively weak coronal hole high-speed stream is currently arriving. Again, that's measured at the F layer of the ionosphere, located at 300 kilometers of altitude. Here is the F layer in its vibrational frequency, or megahertz, millions of vibrations per second, and we're seeing a lot of high-frequency anomalies. The ionosphere, it's extremely unscintillated. So there's been a lack of space weather for quite some time here. And the ionosphere, again, it's at quite high frequency here at the moment. You're going to see mostly high-frequency anomalies. If you're familiar with that map, great. If not, don't worry. Here's the anomalygram. That's anomaly in megahertz from a 30-day median. You'll see lots of blue. Those are the high-frequency anomalies about which I just referred. So that's what's going on. That's the Australian Government Bureau of Meteorology, by the way, that produces this data. Shout out to Kimberly Nichols. And look at that. Massive high-frequency anomalies there. That's 1400 universal time ionogram and 1400 universal time anomalygram. Coming at you kind of late today. We slept in. We are known to do that occasionally here at the Smash News Network, least busted name in news. Next, the Ionosphere nowcast, depicting total electron content and anomaly, maximum usable frequency and anomaly. That's for radio and GPS operators, largely, but it also gives insight into what's going on in space weather. the Ionosphere Nowcast, one of our newest features on the channel. Evolve or die. The only thing that remains constant is change. We also like to show the total electron content forecast by itself, which is looking all jacked up. I don't know what went wrong with it, but here it is. It's showing an insanely low number of electrons there, and I just don't think that's correct. It looks like it might be clearing up here. Something's going on with that. I don't know what's wrong with it. There's probably some funkiness going on with one of the pieces of data that's used to calculate the forecast. I highly doubt the electron contents are as low as that's showing. It just doesn't really make any sense. That's free electrons all the way from the inner portion of the Van Allen belt down to ground level. Your GPS satellite must communicate through that outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere to get the signal to your handset. Those free electrons cause signal refraction, and I just don't think that that is legit data, especially after looking at the total electron content anomaly over North America. See, this looks normal. That global scale map does not look normal. So here's the anomaly from the 10-day average for the total electron content over North America, and we are seeing some minor high electron content anomalies there over places like Mexico. Not a big deal. And it's time to close out space weather with the latest high-res images. So there's the colorized magnetogram. There is the SDO Continuum. There's that new sunspot that just rose. Here's this new active sunspot. There's a new sunspot that just formed right ahead of it. So we'll have an uptick in sunspot number coming today. That group up there in the northern hemisphere is looking pretty weak. I don't think that might not get a name, but there are like 2 more groups over here that'll get names. Also make it 3 new groups over here. 3 new sunspots there in the northeast. So expect a significant uptick in the sunspot number moving into tomorrow. And also the likelihood of large solar flares is quite high, especially from this area here, this group down here. That's beta gamma class. That's beta gamma delta class. And that also beta gamma delta class. Anyway, there's the full disk rock back. And before we do meteorology, take a moment to visit the links below the video. If you haven't checked them out, all kinds of links there. We built a massive web ring starting in February of 2019. We realized we needed our own websites way back then because of pathetic censorship. Yeah, pathetic censorship. It was because of outright bans on Facebook at the time, because we had like our ability to post suspended or something on Facebook. We extended a giant middle finger to Facebook and just started our own websites. So visit our links. You can find them below the video. Help us out with clicks if you're unable or unwilling to open your cobweb-encrusted wallet and become a member of the Smash team. That's the best move as you get additional content. And welcome to the Neo Renaissance. There are all kinds of ways to support the channel. There's even a permanent invite link to the Discord channel on the homepage. You need an invite to join Discord. You can also find the Instagram. We're still on Threads for some reason. Give Smash staff a raise by visiting us on the internet, visiting our paid affiliate / sponsor links, getting involved, leaving comments, pressing share, yada, yada, yada. I wish I didn't have to say all that, but I do, because reasons. Anyway, let's talk about the Beaufort Gyre. The Beaufort Gyre is this area of ice, it's usually ice, north of Alaska here, sort of in between the North Geographic Pole and Alaska. And a lot of people are very spooked. A lot of people are spooked about the Beaufort Gyre. Oh no, it's going to release its water and it's going to create a year without a summer in Europe. Well, guess what, folks? The Beaufort Gyre is now in a freezing mode because winter is approaching and melt season is completely over. Okay, so that's the first thing I've got to say about the Beaufort Gyre. A lot of people are very spooked that the Beaufort Gyre, it's going to melt and all this water is going to rush into the North Atlantic and it's going to shut down the NAO. It's going to come down like this and shut down the North Atlantic Oscillation, and we're going to see a year without a summer in Europe and all of this stuff, and it's it's just hilarious. Yeah. So, yeah, it's, anyway. Here's what's going on now in terms of sea surface temperature anomaly. So, you may notice that there's a bunch of warm water in here. See that? That's warm water. And then there's a bunch of cold water up here, at least anomalously cold water. But if you look at the actual sea surface temperatures, yeah, all of this water is quite cold. 33.9 degrees Fahrenheit. I mean, anyway, we're going to show the whole planet sea surface temperature anomalies. We're even going to head to Global Cryosphere Watch today to show the state of snow and ice on the planet. So there's sea surface temperature anomaly for the entire Atlantic Ocean. That also depicts surface winds. There are the surface winds and sea surface temperature anomalies for the Arctic. Here's the Pacific Ocean, the Southern Ocean, and the Indian Ocean. Okay. Now we're going to switch to our regularly scheduled meteorology segment here. There's the surface wind scenario for the eastern world. Shout out to our viewers from this side of the planet. There are the jet streams from the east. If you're viewing from this view of the planet, leave a comment, press share, tell your friends and foes about the channel. Here are the jet streams of the central world. These are the surface winds of the central world. And like sands through the hourglass of time, these are the surface winds of our lives. As snow begins to fall in Canada. Surface winds of the west, jet streams of the west. A huge kink in the jet stream here, continuing to blow cold Canadian air down into Pennsylvania. It's quite cool here and windy. That crisp Canadian air. As the jet stream is doubled up and converging there over the eastern U.S. So, we're looking at precipitation type. We're also going to show new snow here. So, first precipitation type, because I wanted to show the fact that, yeah, there's snow falling there in Ontario. Wait, that's not Ontario, is it? Is that Quebec? I don't know the provinces. What do I look like? Okay, that is Ontario. Also some in Quebec. Anyway, that's precipitation type, and I just wanted to show new snow. Yeah, new snow. Because like I said, melt season is completely over. So check it out. Here are the next 12 hours of new snow. Let's move back up to the Beaufort Gyre. Oh no, the Beaufort Gyre, it's going to melt all of a sudden, folks. It's snowing at the Beaufort Gyre, okay? That's the next 12 hours. Here's the next 24 hours as massive snows fall in Canada, Alaska, and Greenland as well. And there are the next 3 days. More snow falling. Melt season is completely over, folks. I mean, goodness graciousness. So let's go to Global Cryosphere Watch. We'll start out with snow. So here is the snow cover situation. And I'll first of all note that the snow extent is right in the middle of the multi-decadal range. Right in the middle. Those blue lines are plus or minus 1 standard deviation for snow extent. That's the two-dimensional snow cover. Just the square mileage of snow cover. Snow water equivalent, right at the top, just around 1 standard deviation there above normal. Snow extent there, right in the middle of the range. Very sort of unremarkable there as far as snow. Also, I would note the melt days here for Greenland. There are the Greenland melt days. Zoom out a little bit to show the full map. Greenland melt days. You can see there's only a tiny area here around the edge where you're getting to like 90 melt days. This white area here in the middle, 0 melt days. 0. So, yeah. That's Greenland for you. We'll also show sea and freshwater ice, as ice levels are kind of low in the Arctic right now. However, like I've said, ice will now be building because melt season is long since over. So, but there's the situation. The orange line represents median ice age in 1981 to 2010 for some reason. I don't know why it's not until like 2022, but anyway, that's where the ice is located in the Arctic. Nothing like it was in 2012 when it was almost gone. Now it's really not all that remarkable. And we don't have to show snow again. Let's show clouds. This is Clouds and Fog from the NASA GOES Interactive Weather Satellite Suite. Clouds and fog over the Americas. As we zoom in closer and closer to the lower 48, let's show this low that is bringing the snow to eastern Canada. There it is. It's broken up and stopped rotating. As I basically forecasted yesterday, it moved over a bunch of cold water as it made landfall. And now it barely even resembles a low, although it's still carrying a lot of moisture with it. It's not really rotating counterclockwise at all anymore. Just barely. As it breaks up and merges with another low that was kind of hanging out there over Quebec. Next, your weather.gov map. We've got frost advisories in Kentucky, Tennessee, Virginia, North Carolina, and even in Georgia. Frost advisories there for the southern U.S. as that cold Canadian air makes its way way down. Hard freeze warnings in the mountains of West Virginia. Next, your 72-hour jet stream forecast. There's what's really in control of your weather. The jet stream. It's responsible for moving your weather patterns from west to east. Your weather, it's not controlled by mankind. It's largely controlled by this. Also the heating and cooling. The daily heating and cooling cycles, Daytime, the atmosphere warms up. Nighttime, the atmosphere cools down. The troposphere emits radiation. The lithosphere emits radiation. Anyway, there's your jet stream forecast. It's going to be warming up in the southeastern U.S. in the coming days. That frost advisory will evaporate quickly as warm air moves back into Georgia. You see? Facts. Next, the pressure and precipitation forecast, the same model, the GFS 72-hour. Ta-da! Heavy snows coming to eastern Canada. And a landfall of a powerful tropical system there will bring massive rains to west central Mexico. Look at the snow, also ice. You can expect some freezing rain associated with that system there as that low loiters over eastern Canada. Just north of Lake Huron, it's going to be just hanging out there. Also some heavy rains coming to the Pacific Northwest. Next, our total accumulated snow depth change forecast. And some areas there expecting over 7 inches of snow. Significant blanketing of snow there in Canada. It'll be raising Earth's albedo. Guess what that does? It reflects radiation back into space. Yes, snow and ice. It's shiny. Also some snow coming to the mountains of the northern Rockies and Pacific Northwest. We'll also show total accumulated precipitation forecast in inches, since there are some heavy rains. Some cold, heavy rains coming to some portions of Canada there as well. And look at the rains coming to Mexico. Most of that will miss and fall in the ocean, fortunately. That's showing nearly 2 feet of rain from that system. So at least this current model here is expecting most of that to fall in the ocean harmlessly, instead of causing massive coastal flooding. But there are still some areas there expecting 4 inches of rain there. That's your 72-hour total accumulated precipitation forecast in inches. And we'll close out our forecasts with this from Tropical Tidbits. 72-hour GFS temperature anomaly forecast in degrees Celsius. So a band of hot air there, stretching down the Rockies. That's not coming from Colorado, though. That's coming from jet stream action. So much hot air coming out of Colorado. It's creating atmospheric turbulence. That air is so hot and there's so much of it. Why? Because of utter nonsense that people are saying in Colorado. Colorado, it's like the BS capital of the U.S. What a place. I used to want to go there on vacation, and now, not so much. Anyway, here's lightning. Heavy lightning there around Central America and around Mexico. Besides that, things are pretty chill. Maybe Nibiru is siphoning off Earth's oxygen lightning once again. Oh, noes. We've got a really low number of lightning strikes again, folks. I'm spooked. Are you spooked? Let us know in the comments if you're spooked. Dag! It's not even connecting. It may be NASA's hiding lightning, folks. Oh my God. That is really a low number of lightning strikes, though, for real. Lightningmaps.org reporting here only 20 strikes per minute. A few days ago, we saw over 600 strikes per minute. It is a lightning shortage. Yeah, a lightning shortage. Oh my God, a lightning shortage. We'll close out with Doppler radar. Is that snow falling north of St. Louis? I don't think it is. But anyway, there's the full 50-state view. We'll focus on the lower 48 view and close this thing out with U.S. Doppler radar, clouds and fog. And there's the water vapor map. That should clear things up. When your Doppler is unclear, use the water vapor map if you understand atmospheric physics. It will deliver you from atmospheric ignorance. Anyway, here's the recap. U.S. Doppler radar. You too can forecast your weather. You've got more than enough sets of data. U.S. lower 48, clouds and fog depicted by shortwave radiation. And there is a longer wave radiation, that's 6.19 micrometer infrared radiation, depicting all of the water vapor. And here's me signing off from the Smash News Network, least busted name in news. Thanks again for tuning in. I'll see you soon. In the meantime, may that solar wind be at your back. And just go back to the bunker again, because of all the stupid shit I've heard.